former boss and now peer, even though he's a lot younger, as the chair of the HTA division. How cool is that? So, but we're going to have an exciting afternoon. So, what you got for us, Ernesto?
Thank you. Thank you very much, Don. Yes, as you can see, I had enough time to update the slides and say past chair of IFMB CED, chair of HDD. So very briefly, I think most of you, but I see many young guys down there, so maybe it's worth saying what IFMB is all about. IFMB is the International Federation for Medical and Biological Engineering, or I prefer to call it biomedical engineering, but it depends on you. And the main mission of IFMB is to encourage, to support, represent, and unify the worldwide medical and biological community. And that means a lot of things that we are trying to do together. And many of the things are run by the two divisions, Clinical Engineering Division and the Health Technology Assessment Division. This slide, actually, it is outdated because they didn't have time to do that in IFMB. And those are the two active branches. We have many committees and many divisions, and two divisions, many committees and many working groups. And by the way, also that is something that is changing day by day. In this actual conference here, a new working group has been proposed and approved, a working group on the African affairs. That means that this is a very dynamic structure that tries to follow this very dynamic field that we are involved in. So what is a clinical engineer? This was the first question that I heard when I was born professionally, I would say. And 6 years ago, when I entered and in the clinical engineering division, I remember we've been again talking about that. What can we do to decide once for all? It will never happen. We'll never decide once for all. But what we did, we met in Hangzhou, China in 2015, and we tried to recap what it's all about. So what is a clinical engineer? And on the website of the Clinical Engineering Division, you will find the definition that came out from that summit, that panel of experts. So a professional who is qualified by education and or registration to practice engineering in the healthcare environment, where technology is created, deployed, taught, regulated, managed or maintained related to health services. So very broad, very wide field of application for these professionals. And the clinical engineering division just exploded in the number of people who are involved and who are day by day willing to collaborate. And we started in 7 elected members, and then we had some collaborators and then more collaborators. And now I try to count 65. I'm sure after 3 years, we will meet in Singapore and we'll be double this number most probably. That means that there is also a very wide set of competencies that we are talking about. It's absolutely not just managing the technology, and I'll try to show how wide is this field. This is the impact of the CED and the Clinical Engineering Division worldwide. As you can see, it is day by day trying to expand until we hopefully we will cover the whole globe. And that small arrow there, Iran work in progress, is because Iran was at the Italian conference of clinical engineering a few weeks ago, and they are applying for becoming part of IFMB. So one of the goals of IFMB is also to have people, in the loop, and the same is happening with Africa, and the same is happening all over the world. So what is the CED mission statement? To advance worldwide learning, research, knowledge, deployment, communication. And I will not read everything here, but you can see for each of these keywords, that means that we have 4 or 5 projects, and that means 50 people working behind that. So this is something tough, but really exciting that is happening. So let's give a very quick look to this report. I'm sure most of you know it. Every year it's been updated. So I tried to update the figures. I've been using similar slides in Sarajevo last year when I was the keynote speaker in the Congress of Bosnia and Herzegovina Biomedical Society, and the speaker after me, Almir Padnjevic, is the chairman of that conference. And at that time, the indicator was even bigger than this. If you take a look at the average length of stay in hospital compared from 2000 and 2015, you can see how the length of stay in average is decreasing and decreasing and decreasing. And I was talking to Professor Heikki Terjo a few minutes ago, and he was telling me in Sweden is even lower than this. Is 3. It's really low. What does it mean for us? Well, that means that we have to guarantee that people is then followed at home. I mean, you're reducing the average length of stay, doesn't mean you are reducing the care you have to give to people. So systems is the correct approach. And the same is, if you take a look at this other figure, we're talking about the same thing from different angles. How many hospital beds per 1,000 population? See how much it is decreasing in the last 15 years. I have a direct experience in my city, in Florence. When I started working with them in 1999, it was 2,000 beds. Now it's 1,500. So it's absolutely happening all over Europe in this case, but I'm sure these numbers could be transferred all over the world. And that means, once again, that if you also want to take a third look to the same problem, let's see how the hospital beds are articulated, and you see how the long-term care is shrinking and shrinking and shrinking. That means it's very resonant to the average length of stay. That means that we have to deal with patients outside hospitals, patients at home, and that means ICT, that means IT tools, that means training to caregivers, but also to the patient himself, to his relatives. So quite complicated. And the picture is even more complicated if you notice what is happening with the medical devices. I'm sure you all know that. This is just the patent application in medical technologies field in 2016. And you see how 41% of the whole thing is in Europe, and 59 is the rest of the world. So we're particularly, I would say, aware of the level of complexity that is raising from day by day, I would say. And here, this is the evolution of European patent application. Once again, last year, this slide was summing up at 11,000. Now it's 12,263 for medical technology. Compare it to pharmaceutical. You see how much effort the whole community all over the world is putting in medical devices. And that means opportunities instead of problems. I would say opportunities for all of us to manage. And a few minutes ago, Professor Elliot Sloan was having a talk that we recorded, and hopefully we will play during the next section this afternoon. He was live on Zoom. I had borrowed a couple of slides from his previous talk. Example, enteral feeding pump. Let's do a cost comparison factor. And this means that you have to manage your equipment using well-known techniques that are bordered by different fields. I hope you are familiar with the life cycle cost analysis, or with the TCO, the total cost of ownership. This is something that we should be aware of. And that means in our education courses, call it biomedical engineering course, call it clinical engineering course, call it whatever, but you need to provide our students with this kind of competencies. Otherwise, they will be naked in front of the next challenges they will have to face. So this is one example. We have 2 different pumps. The first one will cost what, 122. The other one is for free. But let's sum up the consumables. So what is the total cost of ownership after 5 years? After 5 years, if you see the numbers, they are comparable. So you need to understand that when somebody is providing something for you to you for free, is this really free? I mean, this is something everybody does at home. When you have a new contract for your telephone or for your satellite TV, and they give you the decoder for free, you want to know, okay, but after that, what happens? And this is exactly the same thing that must be done for medical devices and medical equipment. And then augmented reality, this is entering our field. This is not something that maybe one day might happen. This is happening today. We have many tools of this kind that can be used for education, can be used like in this example, but can be also used, I've seen some examples of using augmented reality and virtual reality for maintenance, for remote maintenance. So the technician locally is guided through augmented reality from remote. This is happening today. It's not something that maybe in the future we might face. Okay? And of course, that means big opportunities, but also big challenges, because this is something that you need to know how it works. Maybe not in detail, but you're gonna have the big picture. Otherwise, you just lose your job. And then let's go back to 2017 with the top 10 patient safety concerns for healthcare organization. And this is a very well-known publication from EGRI. And I highlighted here 3 different concerns. One is the implementation and use of clinical decision support. The other is patient identification. And the other one is inadequate organization systems or processes to improve safety and quality. So what I did is look back to a few years ago, the research that has been done in my lab, and I found a lot of things that are answering this kind of questions. Example, decision support systems, so implementation and use of clinical decision support systems. We tried with heart failure. We have been presenting this in a few conferences, also in IFMBE conferences. We've been using IBM Watson Analytics to understand if with machine learning and smart analytics, we could be able to improve the overall process of managing this chronic, very, very tough and costly pathology. So we had a few more examples. Here, I was in a conference in Chicago, and it turns out that there is a guy in Houston, actually, who is doing this device that captures exactly the same data that are the input for our decision support system. So of course it was quite easy to say you have the patients, you have the hardware, let's use Wi-Fi, let's use internet. We have the decision support system in Italy, and we did it and it worked. So this is something I would say exciting, but it's the answer, one of the answers to those concerns that I was mentioning. One more example, COPD, I've been presenting it here a couple of days ago, a similar decision support system based on machine learning techniques. And this afternoon, there will be one more presentation about chromatic pupillometry, so different pathologies and different tools, but still machine learning behind that, still clinical decision support systems. This is something that biomedical and clinical engineers are doing today. And one more concern was the inadequate organization systems or processes to improve safety and quality. Some more examples. In this case, it was a risk management process in designing a tool, a medical device that is a microwave thermal ablation system. So what you do, well, I think you are all familiar with what MWA is. You have some microwaves that will raise up the temperature of those cells that you want to kill, typically tumor cells. And that is the model on the right of the slide. This is the effect in lab. But once you want to arrive on the market, you have to perform risk analysis and risk management. So ISO 14971, risk identification, analysis, evaluation, control. You can use many techniques, but the first thing that you need to do is process analysis. Once again, you are going out of your competencies. You ask people who do this every day. People from project management know exactly what techniques to use for breaking down processes, but you cannot ignore them. Okay? You have to be aware of how to use that. So we went to the hospital, we tried to understand how the process is, we tried to put this down in a structure, in a breakdown structure. Quite complicated, quite time consuming, but there is no other way to do that. You have to have the single tasks, and for every single tasks, in this case 49 tasks, you have to identify the failure modes, 273 failure modes to analyze. Once again, quite time consuming, but it's worth, because once you identify some risks that need to be mitigated, you cannot go on the market and say, let's hope nothing happens. You will start having mitigation activities, and you will do what we call risk control. So after that, the device has been changed, and now it's on the market. It is something that biomedical engineers are doing today to answer that concern that Ekri was mentioning. Again, concern about patient identification. We do patient identification. We want to do that with RFID. We've been talking about that for years now. There is a concern about EMI and EMC. So what we did was, let's test how dangerous it is, this RFID. So let's buy a couple of sources. Let's go in a hospital, in an intensive care unit, and with those two different sources, much different. One is passive tags, that means 2.45 gigahertz. The other one is for 868 megahertz. So very different. Also in terms of power, one is less than, I forgot the numbers, but yeah, less than 100 milliwatts. The other one is much higher. We're talking about watts. And what we did was, let's take these sources. Let's take how much equipment we can. That's why we went in an ICU, because I don't know any other place where to find so many different and also critical pieces of equipment. And let's test it. So we test from top down, from right to left, and you take your source and you put it 1 meter, half meter, 10 centimeters, and then maybe at contact. And let's see what happens. We tried with defibrillators, with ventilators, with infusion pumps, and so forth. And look at this example here. This is quite interesting. This is a typical ventilator, Servo 900, very diffused all over the world. I've seen this everywhere I go, but it's still very much used. And we tried with that number, 341, and in 2 seconds, you can see the variability and what happened. 282, 346, 373, we are talking about exhaled tidal volume. So what that means is that you are losing control of that piece of equipment. We don't know actually if the number is incorrect, the number displayed is incorrect, and the volume is right, or vice versa. But in both cases, you are opening the loop. You're not controlling that anymore. So this could be something to take into account. And look at this. No patient, this is an ECG in a defibrillator LifePack 9 Medtronic. So no patient should be like this. I don't have it now. Oh, like this here should be, or I should have a laser pointer somewhere. Here we are, should be this, okay? And 1 meter, half meter in contact. You're pushing your source and you see the effect here. But this is not critical because you can see that. I mean, it's quite evident that there is a problem, but this is much less evident. This is exactly what an ECG looks like. And the defibrillator thinks this is an ECG. So it will start counting the frequency of the heart rate without any patient, you know? And you know what that is? This is just coming from a power adapter. a linear power adapter, a switching one, clicks, 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 and it thinks it is a person alive with 83 heartbeat, but there is no patient here. You see, where is it? It is between the pedals. It's the power adapter. So if you have an alarm, just the alarm will not be triggered because of this. Okay, so there are some concerns, but in this case, the major problem was the power adapter, not the source anymore. So power adapter, that means we have a lot of them for charging the your phone, for example. What does it happen when you put it on the infusion pump? I see that every day in our hospitals. Again, process engineering. What about cloud? Cloud makes things a bit more simple for somebody, but a lot more complicated for others, people who have to manage the whole thing. And back in 2008, this is an old slide. Back in 2008, healthcare cloud computing market is estimated to grow twice and reach 9 billion by 2020. So yesterday I wanted to update this slide, and I said, let me see what they are thinking today. 9 billion is quite a number. And this is the actual updated number, 35 billion by 2022. And I'm sure this is still optimistic, or pessimistic, depends on your point of view. So this is a big number to deal with. Internet of Things is now a reality. Every day we have to manage. And what we can do here, example, once again, you select the process, could be the patient identification, could be the drug administration, and you describe that process with the same techniques I was mentioning before. So you break down the process. In this case, we were trying to implement a couple of tools that has been developed in my lab. One is this drug dispenser. The other one is a combined solution software and hardware with RFID to track the position of patients in intensive care unit of a children's hospital in Florence. So same tools. You have to break down the process, you have to analyze it, and you have to describe it with some very known tools like failure mode and FX analysis, or in this case, it's multidimensional, but more or less it's the same. And then you can arrive and describe the state machine to the software developer. Right after that, not before. You cannot develop a software and let's see if it fits in my process. Okay, so quite tough, but this is something that today we are testing in that hospital in Florence. So I could go, but I have not so much time, but I could go further with all those tasks. There are HTM topics, HTM, service delivery management, disaster preparedness, quality procurement, models. So it is a very wide field. Of course, we cannot know everything, but if you think to the biomedical engineers and the clinical engineers should be there. This is not something that we can leave somebody else to manage. And of course, we also have HTM in the first place, but it's not just that. Okay? So if you want to know more about what clinical engineers do, you can just go and take a look at the global ICE htmc.com. That is the Global Clinical Engineering Day website. Every year we have on October 21st, we have the Clinical Engineering Day. And right now you can find, what, 250 success stories, I guess. Every
150, but on the way to 400.
Okay, on the way to 400. That means you may figure out how much clinical engineers and biomedical engineers are impacting on healthcare and on patient safety. So let's just not try to label everything, to label people, to label, but I think the main message here is let's work together to improve the safety of patients, basically. This lasts 2 minutes, so I think I could interrupt this. Thank you.
Okay, Dr. Iadanza, thank you very much. We have time for a couple questions. Anybody?
Kenneth.
Go ahead.
It's done.
Go ahead and ask it and I'll repeat it.
Oh, there's a microphone right there. Yeah.
thank you for the well-articulated presentation. My question is a little away, but it's still okay. I want to find out, I have two questions. The first one is the clinical engineer, because it looks like everybody is becoming a clinical engineer. Like I thought the clinical engineer should be restricted to the health sector, I mean, hospital safety, and so on. Is there any possibility of having clinical engineers in the academia? Because the definition is used. And then the second question is, I thought clinical engineering should be a specialty away from area like biomedical informatics, because it looks like clinical engineering is also going into those areas. I thought there should be a lot of specialty areas in biomedical engineering.
Thank you. Well, you were mentioning the definition of clinical engineers, and you said the academia is out. I think it's not, because where technology is created, deployed, taught. So that includes academia, of course. We all, most of us work in academia, and we still consider us as clinical engineers. And the second part of the question was, should be considered as part of the hospital setting. Was that the question? Could you repeat the question?
I was trying to say that clinical engineering is now, zooming into medical informatics. I thought medical informatics should be a specialty. In fact, almost a standard.
What we call CEIT.
Yeah, absolutely. Yeah. But once again, this is, as you were mentioning, it's zooming there, but it's zooming in many other different fields of application. So that means, as I said at the end of my speech, let's remove these labels. I mean, let's do what we have to do. We have to be there for IT. There is no doubt. We have to be there for ICT. There is no doubt. People is now receiving their cares at home. So are they relying to the standard communication or their phone? Shouldn't that be taken into account? What does it happen if I am telemonitoring somebody and the problem is not the software, it's not the training, it's not the hospital, but it's the phone line? So shouldn't we be included in that? Of course, yes.
What I'm saying is there's that field of medical informatics.
Absolutely, I agree.
And it's an area in biomedical engineering.
Clinical engineering is clearly a wider scope than some believe it to be. Other questions or comments? Come on up to the mic, John.
So what is the plan? As we can see, it's more complex than we think. What is the plan specifically? Now we're moving for anticipatory care, where we have to take care of patients at home. And I think this is taking us by surprise. We take care of hospitals, we take care of all our equipment in the hospital. How are we going to manage those patients at home?
I think the answer is the subtitle of the book that Edward was citing before. We published a book for Elsevier a couple of years ago, and it's called Clinical Engineering: From Devices to Systems. And this reflects exactly what I think should be done. Let's start thinking about systems engineering, because that is the answer. Of course, it's just the approach that we should change, and that means we have to work in team. There is no doubt. It's not like being in the basement and doing the maintenance. I know it's very different, and maybe we are not used to that. But we have to start, and we already started to teach to the young guys how to work together. The tools I was trying to show: project management, collaboration, okay, systems. There is no other way, in my opinion, to try and solve that problem.
Well, as we come to a close, I do have a comment about Dr. Iadanza. he has an unfair advantage on some of us with his risk assessment because of his intimate knowledge of root cause analysis and failure modes effect analysis. He has 5 children and 4 of them daughters. So he does root cause analysis every time they come home late past curfew and decides with them how that's not going to happen again through failure modes effect analysis.
Okay, the only thing I can say is when I left Florence, I knew there were 4, so hopefully when I come back, I will not find 5.
So I was off by 1.
Maybe you know something I don't.
Thank you very much.
Thank you.